Great, thanks to all of you for joining us today for the ELAN webinar on blockchain technology for electronic transfers. If you're not familiar with the ELAN, we are the Electronic Cash Transfer Learning Action Network. We are a network of companies and humanitarian organizations that look at how to effectively use payments technology for humanitarian cash transfers. You can join our mailing list. If you signed up for this session through the Eventbrite, you'll receive a link to our mailing list for updates and more chances to learn from sessions like this. We want to thank the MasterCard Center for Inclusive Growth for making a lot of our programming in today's webinar possible. If you've called in by phone or connected by phone, please make sure that your phone is on mute, and you can use the chat box that you've just used to introduce yourself to ask questions of the presenters at any time, and we'll come back to those during the question and answer session. I'll give a brief overview of the agenda for today's session and then turn it over to our speakers. Today we're going to cover a basic introduction to blockchain technology. Then we'll have a discussion with both of our panelists about some of blockchain's potential applications for humanitarian electronic cash transfers. Then we'll think about where we are now and the next steps in this space. And finally, we'll have time for questions and answers. And I'm assuming that many of you will have lots of questions about blockchain, so please don't hold back. I'll begin by introducing our speakers. We have with us today Vanessa Koh, who brings experience in both the humanitarian and technology sectors. She has served in a variety of research roles in the NGO sector, and she's been working with OCHA on researching blockchain applications for the humanitarian sectors. Vanessa is also a master's candidate at the University of Toronto's Munk School of Global Affairs. Greg McMullen is a lawyer, director of the Interplanetary Database Foundation, and chief policy officer at BigchainDB. Greg is well versed in the legal questions around blockchain technology, especially in questions of privacy and decentralized governance. In a past life, he was a plaintiff side class action litigator in Vancouver, Canada, where he worked on privacy and price fixing cases against the likes of Facebook, Visa, and MasterCard. And with that, I'll hand it over to Greg to introduce us to the basics of blockchain. If Greg is still with us. Sorry, Greg, let me re-promote you. Looks like you've reconnected. Hi, Greg, is your mic working now?
How's that? Is that coming through for people?
Perfect, thanks. Over to you.
Okay, great. Sorry about that. I've just been having some little issues with the audio, so I will load up my presentation here quickly. Are you seeing screen sharing there now? No.
Not yet. And if you could move a little closer to the mic, I think we'll be able to hear you a little better.
Okay, so I'm just going to do a quick little presentation here on what is a blockchain and try and get everyone on the same page before we start. So it's a pretty... I'm sorry, one second. So yeah, no matter how many times you test these plugins, they never seem to work on the presentation day, so apologies for that. So I'm ready now. So at its most basic, this question has a pretty simple answer. It's a special kind of database that has a few unique characteristics. And those characteristics are these three things. But before we can get to that, we have two questions that need to be answered just to kind of give the background necessary to understand it. And don't worry about this, I'll be very quick. First, public key encryption. It's an encryption system based on each individual creating two keys that are tied to each other. One they keep private, and that's the private key. And the other they make public by posting it online or using it online, and that's, of course, the public key.
Sorry to interrupt you, Greg, but we're still having a little trouble hearing you. Is it possible to move any closer to the mic or to speak up a little bit more loudly? Thanks for your patience, everyone. Every time there seems to be a new little challenge. Greg, are you still with us?
Is this better? I'm not sure if your phone or mic better. Is that working better for now for people? Okay, so we'll pick up there again. So public key encryption. It's an encryption system based on each individual involved creating two keys, and the keys are based on each other. One they keep private, and the other they make public. So the idea here is that messages that are locked with one key can only be opened with the other key. So this allows you to do two pretty interesting things. The first one is kind of obvious. If someone wants to send you an encrypted message, they can use your public key to lock it, and then only your private key can open it. So only you or someone with your key can see that message. Now the second one is a bit trickier. If you write a message and sign it with your private key by either encrypting it or encrypting a little bit of text that says this is me or your signature with your private key, then that can be validated with your public key, which proves that whoever wrote the message had your public key. So unless someone else is using your key, it's proof that it's you. And the second concept we need to understand is hashing. When you hash a file, you're performing a mathematical process on it that generates a series of numbers and letters that's unique to that file. So for example, if I hashed this PowerPoint file, it would come out to something that looks a bit like this. And no other file will generate that same hash if you use the same hashing scheme. It's completely unique. And even though it looks random, no matter how many times you do the hash, it'll come out to exactly that same value. So that's true even if someone else generates the hash on another computer or in another part of the world, it'll always be the same. Unless something about the file changes. So if the smallest little bit of information in my PowerPoint file changes, then you generate a different hash when you run the hashing algorithm on it. So that means that if the hash is the same, you know that you're dealing with exactly the same file for an input. And if the hash is different, it means that something has gone wrong and that there's a difference in the file. Someone has changed it. So with that behind us, we can come back to our first question, which is what is a blockchain? And usually when people think about blockchain, they are thinking Bitcoin. Bitcoin is the most famous blockchain, it's the first blockchain, and it's probably the most widely used at this point. So that means that it's a really good example to talk about the basic principles. So really, the Bitcoin blockchain is the database or the ledger that lies underneath the cryptocurrency Bitcoin. So at its most basic, it keeps track of who owns what Bitcoin, and it's used to make sure that transactions on the Bitcoin network are valid. Every Bitcoin address has one of the public keys that we were talking about earlier, and can only be accessed with the corresponding private key. So the Bitcoin network is thousands of different computers around the world running the Bitcoin software. Each one of those computers stores a complete copy of the Bitcoin blockchain, or the database underneath it, which records every transaction ever made on the network. And so when a new transaction is sent to the network, all of those nodes running the software review the transaction to make sure it's valid by checking the signature against that public key and checking to make sure that the public key actually has the money it claims to. So if the transaction is valid, it's combined with a bunch of other transactions into what's called a block, which is really just a group of transactions, and added to all the previous blocks. And you kind of get this long ongoing chain, which is how you get the term blockchain. Now, each of those blocks has the hash of all of the previous blocks included in it. So that means if there's any change in the underlying data, then you can identify it because the hash no longer matches the information that's been stored. So what if something goes wrong? If someone tries to spend Bitcoin they don't have, or if someone tries to change the history of the transactions, the network will review the hashes and review the keys that are involved in the transaction, and it'll reject the invalid transactions and refuse to write them to the network. So they'll just drop off the chain. And because of that, because of this system of validating previous transactions and adding new transactions, it means that we can actually tie real-world value to the contents of a blockchain. And your money file can't just be copied like a music file. So one other important thing about Bitcoin is a field called op return, which is in every single transaction. The field is pretty small, but it is really powerful because it lets you add other information to each transaction. So people quickly realized this meant you could use the Bitcoin blockchain for more than just money. You could put other values that are totally unrelated to money in the op return field and use the blockchain as a database for other records, and that those records would now have the same security features as Bitcoin. One example is our previous company, which records of intellectual property blockchain and allowed people to trade digital art the way they would trade Bitcoin. But there were serious limits with what you could do with the op return field and with the Bitcoin protocol more generally. So there have been other blockchains that have emerged. Probably the most famous, other than Bitcoin, is Ethereum, which is designed as a full computing platform. So rather than just writing small things to the op return field, you can actually have computer programs running in the blockchain itself. So this comes into play when you hear people talking about smart contracts or DAOs, but that's more an expert mode course, so we won't get into that stuff today. Another example is our company, BigchainDB. We took the characteristics of blockchains that we've been talking about and built them on top of existing big data databases. So that allowed us to get past some of the scaling problems with Bitcoin. So rather than just doing a few transactions per second, you can start doing larger scale with some of the same advantages of Bitcoin. And IPDB, which is the not-for-profit instance of BigchainDB that we're rolling out right now. Rather than relying on miners, all of the thousands of computers to validate transactions, IPDB relies on a pre-selected group of caretakers. So that brings us back to what is a blockchain. It provides a decentralized control, meaning rather than having one party that can make the decisions, all of the decisions are made by the network collectively. So if you have one bad actor making a bad decision, it'll be overruled by the rest of the network. It allows the creation and exchange of digital assets because of the power of public key cryptography. We can verify that that an item belongs to only one person and that there is only one version of it. And finally, it stores immutable records of transactions, meaning that no one can go in and change the database in the past, and we can be secure in writing things to it in the future, knowing that the records that we're building on are accurate. So the other big question that we need to get into is, what is a blockchain good for? And that's going to lead directly into the rest of the talk today. Blockchains are great for financial transactions, as we've seen with Bitcoin, as we've seen with Ethereum. They're really wonderful at sending value from one place to another. They're really great at identity, reputation, and qualifications, because you can validate any of the transactions to make sure that the person who's making the transaction is actually the person they say they are. You can do a lot of powerful things with identity. Government-issued identity token, for example, could be validated by a third party without going back to the government. And they're also very good for supply chain management. So tracking physical goods through a supply chain by entering it into the database at every stage. It's very easy to trace back through and validate that the chain hasn't been broken along the way. So I'm pretty excited to get into this conversation today, and look forward to the discussion and fielding your questions later.
Great, thanks, Greg. Before we move on to kind of a discussion of some of the potential applications for humanitarian programming, can I ask a first question?
Sure.
You mentioned that if someone else has your public key, that they could potentially kind of act as you. So what sort of, or you mentioned when you were explaining public and private keys how there was the risk of someone having your key. So can you explain how kind of identity is validated, or that you can ensure that you can avoid someone impersonating you in that way?
I think that's actually one of the big things holding blockchain technology back from broader adoption right now, is the difficulty in teaching people to protect their private keys. Their public keys, it's fine if they're out there in the world. There are places online where people will actually post their public keys in order to make it easier to communicate with them. But in the case of the private keys, you're right that those absolutely must be held secret. And there are different people coming up with different solutions for that, but it's still a major stumbling block. And with the state of computer security, that's a big concern that we should have.
Great, thanks for that explanation. All right, now we're going to have a discussion between Vanessa and Greg, who are going to share some of the potential applications of this technology in humanitarian programming. Vanessa has been working on a paper on this, and so she'll kick us off with some initial thoughts.
Great, thank you. Before I get started, is my mic working? Can everyone hear me all right?
Yep, you're loud and clear.
Fantastic. If I may, before we get started into blockchain use cases, I might just follow up on Greg's introduction on blockchain just to highlight a few characteristics of the blockchain as a database that might be most relevant to today's audience. So the key points that I found most useful during my research was that the blockchain is decentralized, as Greg has mentioned, so you can engage directly with the people on the blockchain without a central intermediary. So I think it's that key aspect of not having that central control that's really interesting. Another aspect is lower transaction costs, because you can engage directly on a peer-to-peer basis without having to engage that intermediary. That creates faster and lower transaction costs. And then transparency and traceability, since it's an unalterable ledger of information and transactions. That information is public and potentially accountable because of those features. Moving on from that, so as Lily has explained in her introduction, I've been spending some time working with UN OCHA looking at different applications of blockchain in the humanitarian sector, looking specifically at what are some concrete use cases for blockchain. So there's a couple that have been fleshed out, but today we're going to focus on 3 in particular: identity cash transfer programming, because this is the ELAN, and protected data sharing. So I'll start with each. I'll introduce what the use case is, what are the potentials, and then I think Greg will pick up from there and maybe highlight the state of research and development and some prototypes in each of those categories. So to get started, firstly in identity. So lack of identity documentation is a key challenge in humanitarian response and early recovery, as they're essential to obtain basic humanitarian assistance and to reach areas of safety, etc. However, in our current system, as it stands, identity is often paper-based and location-based, which is easily lost and destroyed. So the potential for blockchain here is to bypass this issue by providing this kind of accessible and verifiable identification in these situations that are in flux. So it's possible on the blockchain for an individual to prove their existence and identity through this distributed public ledger, so much like an international public notary in a sense. So this kind of creates a personal data management system that individuals can own and control themselves. In addition to affected populations using the blockchain, another interesting use case is for humanitarian actors to also use a blockchain for their staff to prove affiliation without showing documentation. So this is a potential way to remove the inefficiencies when working with multiple humanitarian agencies and staff members in conflict zones. I see that there's a question. I don't actually have a presentation prepared today. You'll just have to listen to me speak. I apologize for that. And with that, I will hand it over to Greg to start talking about what blockchain applications there have been in identity.
So identity is one of, I think, one of the most exciting things that is coming out of current work on blockchain projects. Estonia is actually way ahead of the game with their Identit EE project. That's Identit and then EE for Estonia project, where they are looking at, they've issued national digital identity cards and card readers, and are looking at using blockchain to extend their identity program. There are also some pretty interesting private sector identity projects. One example is Scenario, that's building an alternative social network where you would be the one to hold on to your identity and your personal information rather than a famous centralized social network we all probably use today. Another thing that I'm pretty excited about for identity and reputation is using it for educational qualifications. And I think that's especially relevant in the humanitarian sector. Here in Germany, we've seen refugees coming in at an incredible rate, and they're having difficulties proving the qualifications that they've earned at home. Often they've had to leave without paper documentation, and often the institutions that they had received those qualifications from aren't exactly in the position to be forwarding lots of documentation to Germany today. So in those situations, having tokens issued on a blockchain would allow people to bring those qualifications with them and would allow people in the destination countries to validate them without actually going back to the originating university to do the validation. They could just check against the signing key to assure themselves that it did actually come from where they say it came from. One major roadblock here, though, is especially in the disaster response area, is same with any technology that's going to be used in emergencies, is reliance on internet access and electricity. Of course, all of these technological interventions will only work if there's network access and the ability to power devices. So there's still a lot to be said for paper identification in a situation where you're without power or without internet for an extended period of time.
I do think there are a number of challenges. It is exciting that there have been, this is a more mature application for blockchain technology. As you mentioned, Greg, there is the digital infrastructure aspect that is a key challenge. I think also getting the political buy-in will also be an interesting challenge as this identity application matures in the future. I'm going to move on to discuss a little bit more on cash transfers and how blockchain could be used in that. So cash transfers, as you all know, is a widely employed technology, and it's expected to rise in the future. And blockchain could be potentially leveraged to both support and to address challenges in this application. So since cash transfers are sometimes reliant on digital technology, there's a lot of considerations on data exchange standards, security, privacy, and encryption. So these are all critical to this process. And blockchain can address these considerations. So a shared platform based on the blockchain can allow humanitarian actors to easily share trends and anonymize transaction data, for example, in a responsible way. And this could potentially be built upon existing platforms. Correct me if I'm wrong, Greg. So by having this digital cash transfer platform be based on the blockchain, this could be made more traceable, more secure, and at a lower cost, with the possibility of tracking funds from the original donor to the final recipient, while still ensuring some aspect of privacy and security. Much like, in my head, it's much like crowdfunding and distributing funds directly in a faster and a lower cost.
Yeah, I think that's right. I sometimes like to call blockchains a total surveillance machine because you could trace money going through it or transactions going through it from one end to the other without any break in the chain, which makes it so powerful for things like supply chain, but also has huge privacy implications when you're talking about cash. But that cash is also pseudonymous. It's not totally anonymous because it's tied to your private key. But we don't know what name is tied to that key. So it's still flexible that way on the individual level. And I think at the program level, we probably don't want to be that worried about privacy. We want to see the money flowing through until it gets to the point where it actually should be going to individuals or being spent on actual program expenses. And having that audit trail within some of these programs is probably a very good thing.
Curious though about the potential for blockchain to in responsible data sharing, and I think it's been something that's been coming up in a lot of these conversations is how do you protect affected populations and their privacy, and to ensure that we're not sharing any data or identification for these populations while still ensuring that level of transparency and accountability.
Right. I think there are really useful applications for more standard encryption technology to just to scramble the data that's being written to the blockchain, so we can prove that it's there, but we can't actually see the contents of it. If I, for example, can produce a token from my identity that says that I'm eligible to vote in an election, for example, there's no reason for the election poll to have to see my name, my address, my date of birth. So by design, we can use blockchain style technology and this kind of cryptography in order to do some pretty interesting things like that. But we do have to be careful that we aren't just storing plain text data and people's personal information in a blockchain. And we have to be very careful that these histories of transactions don't reveal more information about people than we intend to reveal.
Great. We've had a couple of questions. Before we move on to talking in more depth about protected data sharing, we've had a couple of questions come in about identity and cash transfers. So let's start with those, and then we'll have more time for question and answers after the next discussion as well. So Shaylee has asked, what feedback have we received from the banking community that has tested blockchain in their transactions? Greg, do you have any insights on this?
There hasn't been a lot yet. We've seen these pilot projects that mostly got started at the end of last year, and I'd imagine we'll start to see some results coming back in the fall. But the pilot projects are still going on. We're still seeing banks getting involved and testing things. So I'd expect that we'd start seeing more results soon.
Sounds good. We also had a question from Paul from Consult Hyperion about how blockchain extends the Estonian e-identity service. Can you expand on that a little bit?
So the way Estonia is treating their e-identity project is kind of as an in-government startup. And their plan is to interface with other startups. So they've kind of just rolled out the platform and they want to see what people do with it. They're having a conference in the next couple weeks, I think, to bring people together to discuss how this could be used and what could be rolled out on top of it. So I think we'll start to see some results from that soon. I'm going to see if I can find the link to that conference and post it in chat.
That'd be great. Thanks. We also had a comment from Rick from Mercy Corps saying that Benku has made progress on identity schemas, which is a fascinating comment. I don't know if you've interacted with them at all or learned about them, Vanessa, from your research, or Greg.
I'm not familiar with them, but I've written
No,
down.
actually, I haven't. So this is a great.
Sorry, Vanessa, I think I talked over you there.
I just said I am not familiar as well, but we'll definitely check it out.
Great. It looks like Rick has shared the link so that those of you who are interested in learning more can visit their site directly. And we'll head back to the last topic of discussion about protected data sharing. So back over to you, Vanessa. Please feel free to keep asking your questions in the chat box.
Okay, thanks, Lily. To continue with this discussion, protected data sharing is a really interesting application of blockchain. If you're thinking about blockchain as a database, you can potentially store anything that has value. And in this case, you could store and transfer information in a sense. And this is a way to address one of the barriers in humanitarian information management, which is information silos between different actors and having unreliable information. And I think this challenge will continue to grow as big data becomes much more prominent and important in the humanitarian sector. So the use case for blockchain here is to provide, in a sense, an information marketplace that's publicly accessible to all users while still ensuring some level of information security. So the example that I found useful was to consider the example of a home address versus the contents of a house. So the home address can be listed publicly in a street directory, but only the owner can access the house with his or her private key. So in the context, the address would be public information, but what's inside the house is private, and only those with the keys can access it and its contents. So in this way, the blockchain can store data and enable sharing, in a sense. So in addition to having that those characteristics, the blockchain lends itself well to being a permanent public records repository. So it has a combination of time-stamped and also verified information that's hosted on this accessible public ledger, which could potentially play an important role in reducing the costs and increasing transparency that comes with humanitarian data. Moreover, due to the blockchain's distributed nature and the fact that it's decentralized, it's possible to have different agencies collect and share data on the same blockchain network, in a sense. So this reduces the cost for protected data sharing while enabling more sharing between entities and to create that information marketplace that I brought up as well. I do think the key challenge here is with data privacy and security. While there are these private keys and digital signatures, there are some questions on how this will interface with data protection laws and responsible data standards.
Yeah, I think data protection laws are going to be a very big issue for this, to the point where a lot of the benefits could be, or at least the benefits from larger public blockchains could be harmed by the various data protection laws because of the nature of blockchains where the information is stored in multiple jurisdictions usually. And the requirements would be that you would comply with the data transfer rules of your home jurisdiction, which might not allow you to transfer things out of the country or store it in certain jurisdictions. It's very difficult to make sure that each of the nodes is actually complying with your jurisdiction's rules. So that's one barrier, and I think the other was already highlighted. The difference between the information that you want to have public, like the house address, versus the contents of the house. Encrypting that information could be one solution before putting it on the blockchain, but there might be some stuff that's just too sensitive to post on a public blockchain to begin with. And then finally, technologically, there are a couple of issues with using blockchains as it is. The first is a scaling question. Um, Traditional blockchains probably wouldn't be able to hit the quantity of information that we would need for that kind of database and data sharing initiative. And secondly, traditional blockchains aren't really as queryable as normal databases. So once you have the information entered in, you won't be able to go find it. And those are kind of the two of the areas that we're addressing with BigchainDB. Adding queryability to the blockchain equation.
Great, thank you both. Do you want to make a couple comments about where we're at sort of with the overall technology? I know you've alluded to this at different points throughout the discussion, but sort of what the next steps could look like and who's taking on those roles, and maybe the timeline if you have any estimate for when we could practically see some of these applications become available.
Oh wow, put me on the spot for that one. As far as where the technology is, I think people have been expecting to see results too quickly. Things are not very far along. Blockchains have only been around since Bitcoin in end of 2008. So really, it's still a very new technology compared to database technology, and we're still really seeing what can be done with it. There's a lot of stuff that is either in beta or in testing phases, and not a lot that is really ready for production in terms of using it in day-to-day, in banking, in logistics for shipping, for large-scale enterprise applications. It's still years away from being ready. But that said, there is some exciting stuff that's happening, and there are exciting initiatives that are coming along to help move us in that direction. One example is the BSafe network that is looking to do a lot of that basic research and development that is needed to make sure that the encryption we're relying on is safe and secure, to work on scaling problems and things like that, to make sure that we can really rely on these technologies when we start doing critical things like identity on top of them. Another is the Interledger protocol, which acts kind of as a bridge between all of these different ledgers, both on blockchain and not blockchain. So for example, paying with credit card and having someone receive the money in Bitcoin and it just being kind of routed through different nodes in the network automatically. And that's really exciting, and I think that removes some of the major barriers to the technologies being adopted. So I think we're not going to be seeing blockchain changing the world in 2017, but I think we'll start seeing major adoption in the next 5 to 10 years for sure. But really, I think individuals, if this is done right, individuals won't have to think about it, because the user experience right now of having to generate and protect your public-private key pair and deal with things like downloading an entire blockchain in order to use a network just isn't feasible for individuals. So I think we really need to get the user experience there as well as the technology that underpins it. So hopefully we'll have the advantages without everyone in the world having to learn anything about blockchain.
Great, that's really a helpful.
I might build up on that as well.
Yeah, go ahead.
Thanks, Lily. If I might just build up on that as well, I do agree that it is a very new technology. However, I do think this is a really interesting space and time period for the humanitarian and other non-commercial applications to start getting involved on how to create the frameworks and to get involved in the research and development of blockchain to, in a sense, frame how future developments are going to happen in blockchain, because it is still new and there's a lot of interest in it. And through webinars and discussions like this, I think we can look at how blockchain could be adopted for specific humanitarian applications, instead of having a commercial application being built and then having to go backwards and apply them to specific humanitarian applications. In terms of the implementation side, I think, in my perspective, it seems that a lot of the technology is rapidly developing. I think the key challenge will be in terms of getting the political buy-in and to develop the policies and the frameworks for how to implement blockchain in a practical sense. I think that'll be a major hurdle to come.
Great, thank you, Vanessa. We've had a lot of good questions coming in and some discussion in the chat. So one of the first ones was from WFP, and HH asks, how can blockchain reduce costs for transfers? And there's been discussion about how could an agency or database deal with the conversion into and out of fiat currencies. Greg, do you have some thoughts on some of the challenges and realities of this link to the blockchain?
For costs, I think it just takes looking at the incredible costs of kind of interbank transfers today to see that a new technology might be able to help with that. It's extremely expensive to move money around the world, even in places with well-established banking systems. So if you allow people to do that directly between themselves with fewer intermediaries, that is probably going to reduce costs. I think I mentioned the Interledger protocol. I'll post a link to that shortly, but that is a really exciting development that is it's really working on ways to move money both between individuals and between different ledgers. So from US dollars to Bitcoin, from Bitcoin to Ethereum, from PayPal to Bitcoin, and to move money back and forth like that through appropriate technical and hopefully appropriate legal channels. It's a big challenge, but the initiative is underway. They're setting up W3C, that's the World Wide Web Consortium that sets internet standards working group, to develop this technology, and I think that'll be pretty significant in the way things shape out as far as moving money across ledgers and in and out of between blockchain and hard currency.
Great, thanks, Greg. In addition, we had a question from Marcella about, kind of practically speaking, who and how would information such as university certificates, ID information, or land title make its way into the blockchain? Who practically would be responsible for entering this information? Vanessa or Greg, if either of you have thoughts on this, it'd be great to hear.
Well, we've had some experience taking existing records from with Ascribe, the company that was doing intellectual property. We had experience taking in records from art institutions. One of the, I mean, it's easy enough just to write software that will automatically take their records and write them to a blockchain. The challenges we ran into were, first of all, the scale of the blockchain not being able to handle the number of records that we wanted to write. And secondly, we didn't have this particular issue, but you could see how it would arise, that the records that you are writing to a blockchain, you need to be 100% certain that you are writing the correct information, because once it's written, it's not going to change. So more than even with a standard database, you want to make sure that that information is right the first time. And I think that, more than just the data entry, will be the major challenge in getting this information into blockchain form.
That's interesting, thanks. And you mentioned that we wouldn't necessarily have to learn as much about the mechanics behind blockchain, and that the emphasis should be on kind of user interface and usability in the first place, which I think gets towards Nick's question of how do we prepare and sort of what should we know now. I think we're at all different levels of sort of understanding the technical explanation that you provided earlier, but what are some things that people should take away from this discussion to understand how they could work with blockchain in the future?
From my perspective, I think sorry, Greg. From my perspective, I think as the technology develops and people will, as Greg mentioned, won't have to know the nitty-gritty of the technical aspect in itself. I do think the key points to take away are that blockchain enables people to speak directly to one another instead of having to go through intermediaries, and that it's unalterable. It's an unalterable record of transactions or information being shared, and that it's transparent. And I think those are the key points that I would take away from what blockchain is and how it could be used.
Yeah, and just to build on that, Vanessa said that that we should be thinking about people dealing directly with one another. We also have to get used to the idea that people can trust one another. And when we're designing these systems for use in blockchain, we have to accept that if we are a third party, we are not going to be adding value as the verifier of information, because people can verify information with each other. We might be the initial validator, but they're not going to have to come back to us every time that they want to prove something. And that should be taken into account when we're designing systems that are going to use blockchain.
Great, thank you both for that perspective. In relation to Marcella's question, we had another question from Shaylee about how the humanitarian community accepts e-identification, and if these kinds of e-identifications that are being created by governments are accepted by other governments at this point. Do either of you know a little bit more about how this has gone so far?
For my research, there's been a tremendous interest by governments. I think particularly in identity and storing public records. I think the challenge will be to get everyone on the same page. As you mentioned, individuals have different levels of expertise in what blockchain is, and that goes for at the government level as well. So there will definitely have to be regulatory frameworks for how to implement and have blockchain being used in the future, and those haven't been created yet, as far as I know.
I'm going to pour a bit of water on the blockchain hype too, and say that in a lot of cases people think that they might need a blockchain because it is the current tech buzzword, but really what they need is a distributed database. And blockchains are very expensive and very inefficient databases if you just need a database. They do what they do very well, but if you don't need these additional security criteria, you're better off looking at a normal database. And I think that's going to be one of the big things that is happening in the way these are rolled out, that people are realizing that maybe we don't need that extra overhead. And I think there's a lot of that in the way government IDs are being rolled out.
Great, thank you. I can see we've had a lot of back and forth about anti-money laundering, or AML, and KYC, or Know Your Customer regulations, and how these could apply. I know it looks like a lot of people are thinking about how this applies in the case of Bitcoin, but obviously making that transition to what this would mean in humanitarian cash transfer programming, which has to be provided or has always been provided to date in a locally acceptable currency or in the form of vouchers for particular products or value in a currency. Do either of you have any thoughts to add on kind of where the responsibility and kind of regulatory framework for anti-money laundering and Know Your Customer regulations is progressing with respect to transfers using blockchain or distributed database technology?
I can't speak for where the state of development is at the moment, but I do think an interesting way to think about it is if there's a way to incorporate those AML KYC regulations within the blockchain, so to have those actually as part of the protocol that you're using when you use a blockchain instead of having those added after the fact. Something to think about as well. I don't know if the potential is there, if there have been any developments in that aspect.
I think, yeah, that would be pretty interesting. Right now, the requirements are pretty burdensome in some places. Everything from making an appearance in your bank in order to have your identity validated, to scanning identification and sending it off to third parties. It can be pretty onerous in order to move money in and out of an account on these various exchanges. So if you are looking to buy Bitcoin or turn Bitcoin into your local currency, you could have a pretty rough time of it unless you're interfacing with these other institutions. And it's interesting to think about whether the cost of meeting those requirements for everyone would be more or less than the cost of just sticking with the fiat currency to begin with. I think especially when you're coming across these issues, when we're thinking about people who may or may not have identification or ability to prove their identification, being met with these additional know your customer, anti-money laundering requirements could make it very difficult for the benefits to be seen here.
Great. It looks like there's a whole discussion going on, and those are some interesting perspectives to add to it. I can sense that there's enthusiasm for a second discussion or going into more depth on some of these challenges and different solutions that could present themselves. We have time for maybe one or two more questions. So if you have additional questions, please add them in the chat box for our panelists. Greg and Vanessa, we can give you guys a chance to have a sip of water. Looks like we've got a lot of other experts participating in different perspectives to add in too. So here we've just gotten another question come in. Oh my goodness. I don't even know exactly what all of this means, Nick. Greg, do you want to take a stab at this one that's just come in?
Sure. On the DAO. DAO is.
Explain to those here what we're looking at or what we should understand from this question.
Sure. So there's the 30-second version of the DAO is, remember I was talking about smart contracts on the Ethereum blockchain. One company decided to make a very big smart contract that was going to be kind of an investment, a managerless, corporationless investment fund, where you could put your tokens and then vote on where that money in the Ethereum currency would be spent. And the catch for this was that there weren't any humans running the show. There was no corporation, no official management team, although there were some people who could say whether the money was spent or not. But essentially, this free-floating ball of what collected $150 million to invest in whatever the people who put money in said should be spent on. So this was going forward. It was supposed to run as a computer program without any humans involved, except voting. But then someone figured out how to hack it and stole about $50 million worth of money from it. So rather than licking their wounds and accepting their losses, the Ethereum developers decided to do what's called a hard fork. So rather than going along in this version of history as if the heist had happened, essentially make a branch off of Ethereum where the heist didn't happen at all, and all of the money is moved back into a different version of the DAO where money could only be refunded to the people who put it in. So there's a big controversy about this because Ethereum was supposed to be totally independent of that kind of interference. It was supposed to be cold, hard, logical code, and now there's humans getting involved. So there's a lot of controversy about how this should be handled in the Ethereum community. It looks today like the hard fork has gone through. I'm going to be on a panel tomorrow that might be live streamed that's just discussing this. So if you want more information, check out the GetD conference, and maybe you'll be able to tune into that.
Great, thank you so much for that explanation, Greg. I realize that we're definitely moving into to level 2 discussion on blockchain technology. So thank you all for your questions and this lively discussion. Thanks to our panelists, Greg and Vanessa, for their perspectives. And we look forward to you on a future